Next on the list, we are going to, again, jump back up to this stream right here, which is our kind of leftovers stream. So you can see what we're doing is we're slowly chipping away at this cube and doing some different operations on all of these different streams, and then we're merging them all back together at the end. So let's just keep that going. Let's do another stream here. So I'm just going to duplicate this. We're going to say delete selected, and this is going to be delete everything less than, say, 0.3. That's cool. It'll work pretty well. Let's go ahead and duplicate this stream, slide it over here. We'll say delete non-selected just to keep our block going here. And this stream, let's go ahead and instead of extruding, let's push these away from the center. Let's push them out so that we're actually breaking up the surface of this cube. Because right now it's very kind of uniform cube still. So we're going to break up the surface of that cube out here on this stream. So again, we're going to use a facet SOP just because we want to process these things individually. And we're going to say make unique points. So now we have all of these things as unique points. You can see that we have 551 at the delete SOP and 912 at the facet SOP. So we have more points. That means we're doing the right thing. Okay. We have all these other noises that we haven't really touched yet. So let's take a look at a couple of these other noises. We've been deleting things based on noise 1, which is good because we want to make sure that we're deleting based on consistent parameters so that we don't end up with polygons that kind of fall into two different streams and then we end up with like weird conflicting geometry. But let's look at like noise 2 and 3. Let's see what those are doing for us. We're going to throw in a color SOP. Just for the sake of visualization, I'm going to highlight this. We're going to change the class from point to primitive, because this is where our noises live. So we just want to look at primitive. And we're going to change the color type from constant to ramp from attribute. And let's look at noise 2. Let's see what that's doing for us. So noise 2 is a pretty low contrast noise, it looks like. Like I can see stuff happening in there. And again, we've frozen time on this stuff, at least just for the moment. But it looks like that's a pretty low contrast noise. So let's look at some of the values in noise 2. And again, if I come over here to my geometry spreadsheet and I hit this little label up at the top, it's going to sort it from highest to lowest, or again, from lowest to highest. So yeah, indeed, the contrast is very low. Our lowest number is 0.39, and our highest number is only 0.62. So the range is very, very limited, which is fine because again, we can change that. We can change a range as much as we want. We have this data. We can manipulate it however we feel like. So let's go ahead and throw in an attribute VOP. We're going to do a little VOP action to change that. I'm going to plug that in here right above our color SOP. We're going to keep our display flag on the color SOP so we can see what's going on out here as we adjust things in the VOP. So we want to make sure to run this VOP instead of over points. By default, we want to run it over primitives because we're dealing with this primitive attribute again. We're going to hop in here. And I'm actually just going to delete out these two. We don't really need them. We're really just going to run operations on this noise 2. So let's bind our noise 2. And then let's also find export noise 2. Cool. So now we can do things in between here. And just like we did before, what we're going to do is a fit range. Just really simple. We're going to take the output of this bind, plug it into value, take the output of the shift, plug it into the bind export. And, you know, we don't see any change because right now it's not doing anything. But noise 2 currently goes from a maximum of 0.62. So let's, you know, just round that up and call it like 0.65. And then the lowest is 0.39, and we'll call that 0.35. So we're going to say our source min is 0.35 and our source max is 0.65. Cool. Now we're seeing a little bit more value difference in there, right? Like we're seeing dark ones, we're seeing light ones. That feels pretty good. That's helping. And we can always increase that contrast too. Like if we start changing some of these values, this kind of behaves a little bit like a levels adjustment, like a little bit of a limited levels adjustment. It's really just like a brightness and contrast kind of thing. All right, that's fine. And I'm just going to change the name of this attribute VOP just so I know what it's doing. So we're just going to call it attribute VOP remap noise 2. Okay, so we're gonna keep this color SOP kind of off to the side here. We're not going to really mess with that one. It's really just there for visualization purposes. So after that, what I want to do is I want to push each of these points outwards, basically based on the value of noise 2. So the darker ones aren't going to move as far, the lighter ones are going to move further. So I just want to push them out from the center. The way I'm going to do that is by taking its position and adding it to a normal value. But I don't have a normal at the moment. Well, I do. It's over here on the vertex. So let's do this. Let's attribute promote our normal value to the points so that we have point normals. So by default, Houdini will show you what the point normals are going to look like, but when it's this dark green color instead of the blue color, that means that it's just a visualization that there's not actually any normal data there. Same thing with when I turn on polygon normals. This one, these little pink or kind of salmon colored normals that we're seeing here, it doesn't mean that there's actually any normal data there. It just means that this is the what Houdini understands as the normals of those polygons. So you can see here, we don't actually have any normals over here on the primitives, but we're still seeing a visualization here. And that's fine. But what we're looking for is we're looking for point normals, because we want to basically add the point's position and the point's normal and make that the new position. So let's give this thing some normals. Let's go in here and we're going to promote the normals from vertex to point. So we're going to say original class is vertex, new class is point. We're going to say normals. There we go. And so you can see those all turn blue. And you can see the normals are always pointing perpendicular to the polygons. And again, it's kind of weird to think of points having normals, but you can almost think of them in Houdini terms as more like orientation or direction for a point. And each of these points on every single polygon has a normal that faces perpendicular to that polygon. So now what we're going to do is we're basically just going to add that point position, the normal value, and then multiply it by this noise value, this noise 2, so that they move at different distances. And I'll show you a couple different ways we're going to do that. We can build it with a VOP first in the visual way, and then I'll show you how to do it with a wrangle. So we'll do an attribute VOP. We're going to plug this in here. We are going to run this over points because we've got point normals. The points are the things that really carry position. We don't really have positions for polygons. Polygons, again, are just sort of a result of their points that they're connected to. So we're going to run this over points. I'm going to jump in here. And what we're going to do is we're going to throw in an add VOP. And we are going to add the point position and the point normal. We're going to add them together. And that's going to be our new point position. Now, when I plug this in, all of these points are going to go flying all over the place. And you'll see what I mean here in a minute. But we'll wrangle it back in. So we'll plug that in here. And there they go. They're pushed way too far out. And it should be stated that these are not actually the proper length of the normals. if I hit the D key with my mouse over the viewport here, and I go to Geometry tab, oops, I lied, the Guides tab, and I go to Scale Normal, these are actually, what we're seeing here is only 0.2 the length of what the normals actually are. If I set that to 1, now you can see why all these boxes are moving so far. And it's because those normals are actually quite a bit longer than they appear in our viewport. I'm going to set that back to 0.2 just so it's a little bit more reasonable. So what I need to do is I need to reduce the impact that these normals are having on my position. So what I want to do is throw in a multiply pop. I'm just going to pop that right in here. And we're going to multiply that normal value before we add it to the position value. And by multiplying it by a float value, a single number, we're essentially scaling it, which is why sometimes floats are called scalars, right? Because that's what they do. They scale things in this particular case. So what we're going to do, we want a number here. I could type in constant and drop in a constant VOP this way, or I can middle click on input number 2 and say constant, and it's going to create a constant node for me. So by default, the constant node is set to 0, which means that when you multiply anything by 0, of course, it's just 0. So you can see as I start increasing this, those aren't flying around quite as much, which is nice. So let's say 0.15, that's fine. But the problem is they're all just kind of going the same distance at the moment, right? I want this to be a little bit more dynamic than that. I want to have these things going at different distances based on that noise 2 value. That would be far more interesting than having these points just pushed out all at the same distance. So let's jump back out to Geo1 and look at what we need to do to make that happen. Because noise 2 is currently on the primitives, and I'm running this action, all of these VOPs, over the points. So I need to get noise 2 onto the points in order for it to work. So we're going to do another attribute promote right before our attribute VOP, and we're going to go. The original class is going to be primitives. We're going to move it to the new class points. We're going to say move noise 2. So now I have noise 2 on my points instead of on my primitives. And we can see that over here. Cool. Now each point in the polygon is going to have the same value. So this polygon, all 4 points are going to have the same noise 2 value. And that's because when we're promoting from a polygon to points, the polygon is only a single value. So each point is going to get the same value, as opposed to going the other way when we have to do like an average or a minimum or a maximum. We basically have to tell Houdini how to process all of those different numbers that may be on the points and put it on the primitive. When we go the other way, all the points get the same number. Cool. So let's hop in here. Let's bind in our noise 2. And let's plug that into our multiply. Let's see what happens. I'm just going to plug that in right there. Cool. Look at that. So now we've got all of these points kind of pushing in different amounts. It's no longer this nice, even kind of wall. They're all pushing based on that noise 2 attribute. And the more I push them out, the more they are different, the more extreme they get, right? Cool. I do want to adjust that a little bit because I don't think it's quite enough. The differences are pretty subtle. I'd like to see those differences be quite a bit more. So I'm going to throw in another fit range, just like this, on my noise 2. We're going to adjust this a little bit. I'm going to make some changes to this. Let's go maybe, so basically I'm just increasing the contrast, if you will. So by changing the destination minimum and maximum, I'm actually able to force this to have more extreme values. And I don't want to go too negative, actually, because if I go negative, I might have points that push inside my box, and that's not really what I want. I only want them to go outside the box. So we're going to push them out, but what I might do is increase my source minimum so that we can see those a little bit more clearly. There we go. Yeah, that feels pretty good. Let's jump out here. Let's do this. Let's take the output of this and just temporarily merge it in with everything else and visualize it, just so I can see. Oh, let's take our rest of this. Yep, there we go. Just so I can see if that feels right. That feels pretty good. We're not going too far, but we're going far enough that it's going to be at least visually interesting to look at. Okay, cool. I'm going to go ahead and get rid of those. There we go. So back to our attribute VOP. So this is the VOP's way of doing it. The wrangle way of doing it, if you want to do this with code, I'm going to do the attribute wrangle. We can actually, funny enough, bypass entirely this attribute promote, because over here we'll be able to relatively easily access our primitive attributes using the code. We could do it in the attribute VOP too. We didn't really need to promote this attribute. We could access it in the VOP, but it's just easier to just promote it when you're dealing with VOPs rather than having more VOP nodes. But in the wrangle, we can deal with it pretty easily. So we're going to do literally the same thing. Let's see what we did here. We basically took the existing position, we added the normals to it, and made that the new position. It was way too far. So then we multiplied the normals before we added it, and it made it a little less ridiculous. It wasn't pushing them way off. But then everything was really even. So we took the noise2 attribute, threw it through a fit range to increase its contrast, and multiplied that in as well before adding to our point position. So we're going to do much the same thing over here in the wrangle, just with code. So we're going to start by saying at p equals. So this is going to be our new point position. And that's going to be, we're going to start by literally doing the same exact thing that we did before, which is at n plus at p. Just like this. And we're going to get the same extreme result, right? Now, there's a nicer shorthand way of writing exactly this. When you say at p is equal to at n plus at p, when you have the same thing on either side of the equal signs like this, you could just write the same exact thing by just saying plus equals at n. And it's the same thing. It's just a shorter way of writing it. So we're just going to do it this way. It's just a little nicer. No difference. Cool. So now we're going to take at n and we're going to multiply that by a value that we can have in a we can have a little bit of control over. So let's say I did 0.15 before. Let's do 0.15. Okay, so that kind of tempers it a little bit. It's not quite as intense, but it's kind of annoying to have to come up here and type in a value. If I wanted a slider, that would be a way easier way of doing this. So what I can do in Vex is I can write a channel function, and that starts with ch for channel. And Houdini likes things, it likes to know what type of channel you're dealing with, and we're dealing with a float channel. It's just a single channel, so it's CHF, float channel. And then I'm going to open parentheses, and inside here, I'm actually just going to open and then close the parentheses, because every open parentheses needs a closed parentheses on the other side. So I'm just going to put it there. And then whatever you put in the middle of that is what your float channel is going to be called. And so in quotation marks, we're just going to call this scale. So open, close quotes, we're going to put scale in the middle. Now, when I click out here, it doesn't actually do anything, and we don't get a slider down here. So what I need to do is just hit this little button right over here. And what this does is it goes through all of my Vex code, in this case, not very much, and it finds any of these little channel functions that doesn't currently have a channel slider in here, and it makes a channel slider for you. So we're just going to hit this, and there we go. We've got our little scale slider. And by default, it's set to 0, of course, but now I can slide this up and down, and they're linked, which is great. We'll just take this back to 0.15. Very cool. So the next thing we want to do is we want to get that noise2 attribute. The noise2 attribute currently lives on the primitives. Okay. So what we want to do is we want to throw in, now we could take the output of this attribute VOP, but I want to show you how you can access a primitive attribute from a point wrangle rather than having to promote all the attributes all the time. Promoting attributes is totally fine, but it can lead to kind of confusing things down the line. If you're promoting attributes all over the place, you don't know where they live, it could potentially cause some trouble or maybe some loss of data or whatever if you're doing it a whole bunch. Anyway, we're going to try it this way. So what we're going to do is use the prim function, and what the prim function does is it basically it pulls in a primitive attribute from a data stream. And what the primitive function needs, the very first thing that it needs, as with a lot of these functions, is it needs to know the data stream to pull the data in from. And so what we have here, we have 4 inputs. It needs to know which one of these 4 to look for this primitive attribute on. Well, we're looking at the very first input, which in computer language is actually input 0. I know it says input 1, but it's actually input 0. So we're just going to put a 0 here. The next thing it needs to know is what is the name of the primitive that it should be looking for. In this case, it's noise2. We're going to put that in quotation marks because it's a name. It's a string, essentially, inside this primitive. The last thing it needs to know is what is the primitive number it should be looking at. And we're going to put at primnum, which is going to be the primitive associated with whatever the current point being processed is. And it is angry, and I think that's because I got that backwards. Let's say at primnum and 2. Nope, it's just mad. Oh, nope. I figured it out. Noise2 at primnum. Right now, there's nothing between my channel and my primitive. We need to multiply it. There we go. Now we got it. Okay, figured it out. So now what it's doing is it was all mad because we didn't have the multiplier in there. It doesn't know what to do if you don't have anything in between these two things here. So it was upset. But now that's all cleared up. So right now we have that primitive noise2 coming in here, which is great. And it's fine. It's not spectacular, but it's fine. What we need to do is actually increase the contrast, kind of like what we did here in the attribute VOP, where we included this fit range, and we changed some of these numbers around so that it added a little bit more contrast, a little bit more visual interest. We're going to do the same exact thing in the attribute wrangle, and we're going to do that with a fit function, which is basically just the vex version of a fit range node. So we're going to do a fit, and then I'm going to open a parentheses, and just to make sure that I do it, I'm going to close the parentheses on the other side. We're just going to put this primitive function inside our fit function. So the fit function takes 5 inputs, and each input is separated by a comma, or it takes 5 arguments, I should say, not inputs. So the first one is actually just this primitive function. The first one is the source. The second one is the source min. Third one is the source max. Fourth one is the output min, and the fifth one is the output max. So that's what we're going to put in here. We're going to say, I believe I put in a minimum of 0.3 and a maximum of 1 for the inputs. And then I want to say it went from 0 to 4 for the output. So what we've got is we've got a fit function that's kind of all of this stuff is inside the fit function. The source for the fit function is this primitive function that's pulling in my noise2 primitive. My noise2 primitive attribute, I should say. And then it's remapping from 0.3 to 1. It's remapping that range to 0 to 4. So quite a bit more extreme. When I click out here, we'll see that. There we go. Just like that. So it's literally the same exact thing as what's going on here in the attribute VOP. So you can see the attribute VOP, this fit range actually takes 5 inputs as well. It's just we have sliders for 4 of the 5, right? So the first one is the value, which in the wrangle is this primitive function. And then source min, source max, so that's 0.3 and 1. And destination min, destination max, so 0 and 4. Same exact thing that we get over here in the attribute wrangle. Source min, source max, destination min, destination max. That's it. That's all it is. Cool. So 2 identical results from 2 totally different methods. Okay. So you might be wondering, how on earth did I know what this prim function was expecting and what this fit function was expecting? Like, how do you find that out? The side effects website is actually a really fantastic resource for that kind of thing. There's this little help button up here as well that I think you can search through, but I always just end up Googling these things. So here's the entry for the prim vex function. Now, you do have to be a little bit careful because the vex and the Houdini expressions oftentimes share functions, at least the function names. What it requires is actually a little bit different. So make sure that you're looking at the vex function for prim, not the expression for prim. 2 different things. So this is telling us up here what it's actually looking for. What it wants is it wants the type. In this case, we don't have to really worry about that so much. We could, if we were doing some other fancier things, we could do that. But what we really want is the prim, right? So prim is the function, and it's got open and close parentheses. It wants the geometry string, the geometry stream to look at, which in our case was 0 because it was stream 0. That's this one right here. It wants the string attribute name. So the fact that this is a string should tell you that that needs to be in quotation marks, which it is, right? So noise2 is in quotation marks. Anything in a string should go in quotation marks, generally. And then int, it's looking for the primitive number. And in our case, we basically just want whatever primitive number is associated with the currently processed point, because a wrangle, just like a VOP, it runs over all points every single frame pretty much simultaneously. So at primnum is what Houdini understands as the primitive number of the currently processed point. So each point in this case has a respective primitive number that goes with it because they all belong to a primitive. Cool. The fit function, much the same way. If we Google up the Houdini fit function, there we go. So this is actually the fit expression. You got to be careful. This is an expression function, not the vex. We want the fit vex function. It's a different thing. There we go. So it is looking for a float value. So it's not looking for a vector necessarily. So down here, it's showing you what it wants for a vector. For a vector, it wants consistent vectors throughout each of these inputs. For a float, it wants consistent floats. You can't really mix and match because it doesn't know how to blend between a float and a vector. So it's looking for a float value, a float original min, float original max, float new min, and float new max. Now, each of these could be their own function, or it could be channel sliders or whatever. Right now, I just plugged in some numbers, but all they are is just separated between commas like that. And then for our float value, that of course is our primitive function, because that's the input value that we're looking for. Cool. Hope that makes sense. The side effects website is actually a really, really good resource for learning and understanding all these things. Okay, let's go ahead and continue on. I'm gonna just stash the attribute VOP direction off to the side. We're gonna continue with the wrangle. So the next thing I want to do is, right now these things are all kind of flat, right? I would just want to extrude them. So we're just going to do an even extrude on these. So we'll just throw in a poly extrude like this. And we'll just extrude them all in even distance. I do want to make sure to output the back though, so that they're enclosed shapes. We'll just extrude them, say a distance of like 0.1. That's fine. They don't need to be super thick. I don't know, let's go 0.02. Give them a little more volume. So you see how in the viewport they look a little funny, right? Like they don't quite look right. You get this like weird shading. They look a little broken. You can fix that. It's not necessary. You don't have to fix it. But it's because we don't have any normals on our vertices right now. Our normals are actually on our points because we are using them for pushing all of these polygons around. We can actually just throw in a normal SOP after this, because we don't really need those point normals at the moment. If I throw in a normal SOP, that clears it right up. It's just going to throw normals in the vertices. It should also be stated that this cusp angle here, this is the same thing as a Phong angle in Cinema 4D. So like the lower you get, the more kind of faceted things will look, and the higher you get, the smoother it will look, right? So like if I go too far, if I go above 90 degrees, we're going to get that kind of weird, gross look again. I'm just going to keep this at the default 60. That's fine. Okay. Next thing we want to do is I kind of want to connect these back to the rest of the cube, because right now they're just going to be sort of floating out in space, which is a little weird. I want to have a line that kind of connects these back to the cube, or at least kind of connects it to the inside structure of the cube. I'm pretty much done with this stream at the moment, but I am going to branch this stream off and do some things. I am going to throw in a null object, basically just to terminate this. I'm going to call this out. We'll call this out flying. Helps if I can spell today. Polys. Because they're flying out. Great. Sure. Go with that. So what I want to do is I want to branch off of this stream. I'm going to take these and move these to the other side just to keep them there. And before the poly extrude, what I want to do is I want to find out where the center of each of these polygons is, and I want to create a point there. Now that's actually something that we did back here. If you remember right, we actually found the center down here and used it to copy these tubes onto for our kind of weird extruded box wall things that we were making. So the thing that we did to do that was to use this assemble SOP, and this assemble SOP set to create packed geometry is what allowed us to get a point in the center of each of those. So we're going to do the exact same thing up here. I'm just going to throw in an assemble SOP, and we're going to take the output of the attribute wrangle, pipe it right into the assemble SOP, and we're going to say create packed geometry. Now we're going to look at the points. You can see that gives us a point at the center of each of these polygons. Awesome. Now I actually don't need the polygons anymore, so I'm just going to delete the polygons and keep the points. We're just going to throw in a delete. I'm going to say keep points. We're going to get rid of this exclamation point. and say delete all polygons. There we go. Awesome. Well, now I just got a bunch of points kicking around. It seems counterproductive. What I want to do is I want to create a duplicate copy of the exact same points, and I want to move them to a new position, and then I want to connect the 2 points with a line. So we can totally do that, of course. We are going to grab these points. First of all, we're going to offset them. And I want to offset them based on the normals. Now, the normals were way back up here. I have these point normals. I want to take the existing point normals, and I want to make sure that those end up on my assemble SOP. So again, I want to transfer that attribute, the normal attribute, to all the points, so that down here at the delete SOP, I actually have normals on all my points. Cool. And what I'm going to do is break this into 2 separate streams. I'm going to keep these points in one stream and keep their opposite points in another stream. So what we're going to do is throw in an attribute wrangle, and I'm just going to do this really quickly. Over here in the attribute wrangle, we added the position to the normals. This time, we're actually going to subtract the position of the normals. So we're going to say at p. So before we did plus equals, this time we're going to do minus equals. Same exact thing. At n. And what that's going to do is it's going to subtract the normals from the position. Now I do want to multiply that. I'm less concerned about where they exactly end up, as long as they all end up inside the cube. I'm mostly okay with it, but I do want to have a little bit of control over that. So I'm going to add a float channel, so CHF for float channel, and then open and close parentheses, and then inside the parentheses is just a string that is going to be the name for my float channel. In this case, it's going to be distance. And then, of course, I have to hit this little thing over here, and it's going to create this. Now, I didn't throw in the multiply again. Seems to be what I'm just doing tonight, is just forgetting all my multiplies. But there we go. Now it multiplies. So you can see what it does is it's pushing all of those points in the opposite direction of its point normal. Cool. Okay. So now what I need to do, let's turn off this normal visualization. I need to connect these points and these points with a line. And in order to do that, I'm going to use an add SOP. And an add SOP does lots of things. You can add a point in space anywhere you want. In this case, we're going to add a polygon, and we're going to add it by group, and we're going to add by attribute. So we need to create an attribute that is the same for all of these points as it is for all of these points, and it's going to know that way how to connect the points up. So we need a attribute wrangle before we even get into the delete SOP. Actually, I lied. It's going to be after the delete SOP. Because the delete SOP, all that's doing is just getting rid of all the polygons. So after the delete SOP, we're going to make an attribute wrangle, and then we're going to feed that into this other attribute wrangle. This attribute wrangle, all it's going to do is we're going to create an ID attribute. We're just going to call it at ID is equal to at PT num, which is the point number. So essentially this number over here. So you'll see this ID value, 0 for 0.0, 1 for 0.1, 2 for 0.2, etc., all the way down. All these points have the point number is the same thing as the ID number. And that's going to be true also for these offset points. The same exact points, all they're doing is moving in space, but we have 0.0 has an ID of 0, 0.1 has an ID of 1, etc. The reason we do that, the reason that we don't just use point number as our attribute, is because what we need to do is actually merge all these points together. So we're going to merge the original points with the offset points. And so now at the merge, we actually have double the number of points. But the IDs remain the same. So point 0 also has an ID of 0. However, if I look at my ID attribute list, if I click on this little label up here, you'll see that I actually have two IDs with 0. I have point 0 and I have point 228. Same thing with 1. I have point 1, which I would expect, but then I also have 229, and that's because we've also got the same exact points over here with the same exact ID numbers. So now we have 2 points with the same ID. That we're going to use with our add SOP. So we're going to come down to the add SOP. We're going to say we're going to add polygons by group. We're going to change the add mode to by attribute, and we're going to put the ID name as ID. There we go. Fantastic. Look at that. Now we've got all of those lines. And so now we can go back over here to my float slider, and we can actually increase or decrease the length of those lines, which is great. So this, I'm going to throw in a null object at the end of this guy. We're going to call this outlying lines. And we're going to take all of this and we're going to merge it, and we're going to look at what all of this looks like. So we're just going to throw these into the merge SOP, and we're just going to temporarily grab this, which is all of our leftover polys, and throw that in there as well so we can look at everything. Cool, look at that. So we've got all of those polys are now being pushed out, and not only are they being pushed out, they're being extruded, and then they're connected back to the inside of the cube through these lines. That's pretty cool. Feels like they're all kind of connected to that cube now. And of course, we can always come back up here, and we can say, you know, I want to increase the distance in which those sit, and because it's all being tied to the same data, I have this float slider. And because it's affecting everything downstream from it, it's all connected to my slider. So I could even animate this out or whatever if I wanted, which is pretty cool. Nice.